The Dcc Micro-Hite 3D Dcc Cmm is a product of Hexagon Metrology, which is also a Swiss-made device, which is also part of Brown & Sharp. It's a conglomerate of different CMM machine companies that have come together and merged over the years and become one. In today's video, we're going to do startup, homing, and calibrating the Dcc Cmm. In this particular part right here, I'm getting ready to video for you, is the homing of the ball and the stylus. And then we're going to measure a few parts on the machine. During the setup of the machine, going through your lab procedure manual, steps 1 through 24 have been actuated. As you can see on the screen here, we have PC DEMAS CAD 2009 MR1 release. And at the bottom here, you'll notice it says Start Alignment 31, waiting for feature T1AOBO with sphere contact. And that's what we're going to do next. Now we're going to home the machine by gently tapping the ball. Then we'll press auto and continue. Now, following the joystick measurement procedure, so on page 4 of Laboratory 8, we select this symbol, and then we move to tap 3 points, which would be plane, line, line, plane, line, line. We choose it. We move the probe to tap 3 points at the top of the part, which I've already done. Now tapping 3 points gently. Now clicking Next to reference feature, type 3D. Using the joystick, we will capture 2 points in the front of the part here. Clicking Next, using the joystick again, we will tap 2 points on the side here, ever so gently. Clicking Finish puts us in a whole new frame. You'll notice that it shows the tool, the probe, if you will, and down to 0, 0, 0. This is interesting up here. Notice X, Y. This is interesting. You'll notice that X, Y, and Z does not say 0, 0, 0. Moving to the actual probe and using the joystick and roughly positioning the probe close to what we think is the origin, without hitting it, you will notice that x, y, and z is approximately 0, 0, 0. Now, we're off by 100 thousandths on x, but as you saw in the previous shot of the probe, it was off by about that amount. Now we will position the probe to capture the diameter for hole A. You have to be very gentle with this probe so you get it in the right place. And then you gently go down in the hole with the probe. Put it approximately 150 thousandths or so down into the hole. And per the lab procedure, we select this icon, come over and select the diameter, measure circle. Move the probe to capture the 3 points. The joystick is on. And we move the joystick to capture the 3 points. Pressing finish. Scrolling up through the edit window, you'll notice circle 1, as listed in your lab procedure. At the end of ACLT, your diameter is 0.4744 inches. Measuring the line, first step C, we move the probe to the left side of the part to obtain dimension. In this sequence, press this button and then change it to plane against plane. Setting the measurement for line, type work plane and Z+. A little tricky to get it down to this step the best you can without crashing into the lower step. Very difficult to do. Hitting next for 1 point. Press next. Leave your plus and minus tolerance at 4/10,000ths and 2D. Press next. Finish. Now looking at point, this is going to be point 2 on this particular measurement we did because we skipped the second hole, but on your procedure you notice it says 0.3 ACTL. In this case, ACTL measurement, first line on the number, this is your distance in your measurement sheet. First number on the line. It's 2.3606. That's your dimension between the step and the left side. And that brings to a close this brief demo on the usage of a Tesla Micro-Hite Dcc Cmm 3D machine.